Hello friends, so in today's video we will be discussing divisibility rules 2.0. Our agenda for today's video is we're going to learn some divisibility rules from number 6 to 9. Friends, if you have not yet watched our previous video, which is divisibility rules 1.0, I've given the link in the description box below, so please do click on it and watch it. In that video, I have clearly explained the divisibility rules from number 2 to 5. Okay, so we will be learning the divisibility rules from number 6 to 9 and then some tips to consider. Divisibility rule. The number considered to be divided by another number when the quotient is a whole number and the remainder is 0 is the rule of division. Consider two natural numbers a and b. When a is divided by b, if the remainder of 0 is obtained, then we can say that a is divisible by b. Now, what is a divisibility rule? A divisibility rule helps us to quickly identify whether the given number is divisible without actually performing the division process. The rule for 6 and 7. Test of divisibility for 6. A number is divisible by 6 if the unit digit or divisible by 2 and then the sum of the digits should be divisible by 3. So our first step is that the unit digit are divisible by 2 and then our second condition is that the sum of the digits are divisible by 3. Now let's consider an example 3324. As per our first condition, which is the unit digits should be divisible by 2, so we have a 4 in the units place, so 4 divided by 2 is equal to 2. Yes, the first condition is satisfied, and then our second condition would be the sum of the digits are divisible by 3. So 3 plus 3 plus 2 plus 4, which is equal to 12. And then we have to check whether the result is divisible by 3. So 12 divided by 3 is equal to 4. Yes, it is divisible because we are getting a whole number and the remainder is 0. So we could conclude that 3324 is divisible by 6. So we can write a yes here. And then our second example, 642. As per our first condition, the unit digits should be divisible by 2. So 2 divided by 2, which is equal to 1. Yes, it is satisfied. And then our second condition is that the sum of the digits, which is 6 plus 4 plus 2, equal to 12. And then when we divide 12 by 3, we get 4. We are getting a whole number and the remainder is 0. So finally, we could conclude that 642 is divisible by 6. Now, let's consider our last example, which is 68. As per our first condition, again, our last digit is 8, which is the unit digit, so it has to be divisible by 2. 8 divided by 2 is equal to 4. And then our second condition is that the sum of the digits, which is 6 plus 8 equal to 14, are divisible by 3. Now, 14 divided by 3. We do get a whole number, which is 4, but the remainder is 2. So when you divide 14 by 3, is equal to 4 and the remainder is 2. Always remember that we always have to have a remainder equal to 0. So we could conclude that 68 is not divisible by 6. Test of divisibility by 7. For 7, our first step would be we have to double the last digit and then we have to subtract it from the remaining digits. So again, Our first step is that we have to double the last digit and then we have to subtract it from the remaining digit. If the result is either 0 or divisible by 7, then the given number is divisible by 7. Consider an example 224. As per our first step, we have to double the last digit, so 4 into 2, which is equal to 8. And then our second step is we have to subtract it from the remaining digit. So the remaining digit in the given number is 22. So 22 minus 8, which is equal to 14. So and then we have to check whether the result is divisible by 7, or if it's a 0, then we could conclude that it is divisible by 7. So now let's check whether it's divisible. So 14 divided by 7 is equal to 2. We are getting a whole number and the remainder is 0. So we could finally conclude that 224 is divisible by 7 because it satisfies both the two conditions. Now let's take our second example, which is 4446. As per our first step, we have to double the last digit, which is 6 into 2 equal to 12. And then our second step is we have to subtract it from the remaining digit. So 404 minus 12, which is equal to 392. And then our third step is that we have to check whether it's divisible by 7. You get the answer as 56. As you're getting a whole number and the remainder is equal to 0, you could finally conclude that 4446 is easily divisible by 7 because it satisfies the two conditions. And then now, our final question is 614. Now again, we have to double the last digit, which is 4. So 4 into 2 equal to 8. And then our second step would be 61 minus 8 because we have to subtract it from the remaining. So 61 minus 8 is equal to 53, and then when you divide the result by 7, you are not getting the remainder as 0. Rather, you're getting the remainder as 4. You're getting the remainder as 4. Right, friends? So always we have to get the remainder as 0. Hence, we could say that 614 is not divisible by 7 because the remainder is not 0. Now let's see the rules for 8 and 9. Test of divisibility by 8. A number is divisible by 8 if the last three digits, which is the hundreds, tens, and the units place, is divisible by 8. Now let's see a question 2720. As per our condition, the last three digits, which is 720. So if we prove that 720 is divisible by 8, then we could say that the whole number is divisible by 8. So 720 divided by 8, which is equal to 90. As we are getting a whole number and the remainder is 0, we could easily conclude that 2720 is divisible by 8. Again, now let's take a second example, 4240. Again, we have to consider just the three digits, the last three digits, which is 240. So when we divide 240 by 8, we get the answer as 30. As we are getting a whole number and the remainder is 0, we could conclude that 4240 is divisible by 8. Well, friends, remember it does not matter how many numbers you have. In the sense, you could even have 5 digits or a 6-digit number, but when you're seeing the divisibility for 8, you must only consider the last 3 digits. Now let's take our third example, which is 140. Again, as there are just three numbers here, you have to take the whole number, which is 140. So 140 divided by 8. Friends, you could easily see here that you are not going to get the remainder as 8, and also you could easily say that 140 is not divisible by 8. So you could finally conclude that 140 is not divisible by 8. Now let's see the divisible rule for 9. A number is divisible by 9 if the sum of the digits is divisible by 9. Now let's see an example, 198. As per our condition, the sum of its digits should be divisible by 9. So 1 plus 9 plus 8, which is equal to 18. So we have to check whether it's divisible by 9. So 18 divided by 9, which is equal to 2. So finally, we could conclude that 198 is divisible by 9 because the sum of the digits was divisible by 9. Now let's take another example, 8271. So again, we have to take the sum. So 8 plus 2 plus 7 plus 1, which is equal to 18. So we have to check whether it is divisible by 9. So 18 divided by 9 would be equal to 2. Again, as we are getting a whole number, we could conclude that 8271 is divisible by 9. Now let's take our last example, 771. So we have to take the sum of its digits. So 7 plus 7 plus 1, which is equal to 14. And then when we divide the number by 9, we could see that 15 is not divisible by 9 because we would not get the remainder as 0. So we could finally conclude that 771 is not divisible by 9. Thank you friends for watching our video till the end. I will be visiting you with more videos shortly. Until then, goodbye friends. Thank you for watching our Chutti Mithran videos friends. If you like our video, please do subscribe to our channel and press the bell icon to get immediate notification on our new videos. Please do like our videos and share your valuable comments in the comment box below. Thank you and have a great day friends.